All right.
So good morning, Specca mathematical geniuses, Specca Spartans, whatever you guys are gonna be considered. I know you guys are dope at what you do. Good morning. I hope you're here. I'm glad that you're here, and let's get this roll started.
Mr. R, I'm going to give you hosting privileges this one, okay?
Sounds good.
Or, okay?
Yes.
Here we go. All right, so the video is about 2 minutes long, and it's going to go over how you find the GCF and LCM, and then we're going to get right to work and do like 6 or 7 practice problems. That's today's agenda and the exit ticket. Yeah.
Can you guys hear me? Can you guys hear me?
Yes.
Sorry.
Yes.
I just took off the headphones. That's why I'm asking.
Yeah.
All right. Gotcha. Let me put this down here. So, first step, watching the video.
Hey scholars, I just wanted to review the difference between the greatest common factor and the least common multiple, because I noticed in class the other day, when we did GCF, we got it. And when we did LCM on Thursday, the other day, we got a little confused. So I wanted to clarify that up for you. So what I did is I created a quick little video for you. So I'm gonna share my screen and I'm gonna show you the difference. So, okay. When we are talking about finding the greatest common factor, which is on the left, where my cursor is, when you see the word greatest common factor, immediately you need to think of the words greatest, maximum, and most. And when you find the greatest common factor, what you're going to do is you're going to list all the factors of the number. So let's look at my friend 6 and 12. We want to find the greatest common factor of 6 and 12. So what we do is for 6, we want to list all the factors in order from least, which is the smallest, to greatest, which is the largest. So let's start with 6. We know that 1 times 6 is 6, and we know that 2 times 3 is 6. Those are the only factors that make up 6. Let's look at 12 in orange. Well, to get to 12, we know we have to multiply 1 times 12 is 12. We know that 2 times 6 equals 12, and 3 times 4 equals 12. Now that we listed the factors, we're going to look at what's in common in both. Both 6 and 12 have a 1, they both have a 2, they both have a 3, and they both have a 6. The greatest factor that is shared between 6 and 12 is 6. Therefore, that is the greatest common factor. We call that the GCF. Let's look at now the least common multiple. When we see the word least common multiple, also known as LCM, we think the least or the smallest, and we're going to skip count, which means we write down all the multiples, which are the products. So let's look at finding the LCM of 5 and 10. So we're going to list all the multiples of 5, 10, 15, 20. We're going to list all the multiples of 10, 20, 30, 40. Now let's look at the purple and the pink, and we notice that both 5 and 10 have 20 in common. Therefore, that is the least common multiple, which is the smallest number. And I hope that this has helped you.
So hopefully you guys seen that. I can't back out of this. I don't know why. No, that's the trash. I don't want to do that.
So as Mr. R X's that out, today we'll be focusing on finding the greatest common factor and the least common multiple, understanding that there's some keywords and numbers that go with each one. So for example, I'm just going to tell you what the notes say. The greatest common factor is the factors that are shared between the numbers, right? And as you saw, we listed all the factors. The LCM, the least common multiple, is the smallest number that's shared. Those are the multiples you skip count. Now, when you go to the next page on page 2, there will be,
You're looking at my screen, right? Can you see it?
I cannot see it.
Can you guys see my screen?
I don't know how to get it back. How do I get it back, Mr. R?
I'll stop sharing and share again. Apologies.
I just see my desktop. I don't see yours.
I'm sharing now.
Oh, there we go. When you find the greatest common factor and the least common multiple, right? We just went over some keywords. You're always going to see GCF, greatest, maximum, most. And when you say LCM, you're always going to see the smallest or least. As you can see here, if you look, scroll up where it says GCF in purple, it's the biggest number that is a factor for each number. Wait.
You said in purple. I don't know where you see.
There we go, right here, the chart. And then, so the factors of 12 and 9, right? 1 times 12, 2 times 6, 3 times 4. And 9, 1 times 3 and 3 times 3. Obviously, we see that both 12 and 9 share a 3. Therefore, that is the greatest common factor, or the GCF. The least common multiple, least L common CM multiple, is when you skip count. So we're going to find the multiples of 6, right? 6 times 1, 6, 6 times 2, 12, 6 times 3, 18, and 6 times 4, 24. We're going to then list the multiples of 8. 8 times 1, 8. 8 times 2, 16. 8 times 3, 24. Then you're going to circle what they all share. And the only common multiple, or fact, the only common multiple that they share is 24. So that is the LCM. So the way we like to remember this is that what LCM means you multiply, and when you multiply, the numbers get larger. LCM multiply, GCF factor. Make sense? All right, let's look at problem 1. Mr. R is gonna model that one for you.
Yes. So, guys, first problem. Eric is putting together snack bags for his classmates. He brought 18 bananas and 9 strawberries. Each snack bag will have the same number of bananas and strawberries. What is the greatest common number of bananas? So the way I would actually do this, guys, is that I would actually underline the key factors. In this case, it's 18 bananas and 9 strawberries. We have the greatest number and the same number, which all go into the first box of annotation, right? So the way I want to do this is just like so. I have 18 what? Bananas. And then I have 9 strawberries. I might put this a little bit. Sorry guys, that is so small. I also have same number. Then I also have the greatest. Now, why do we write this down? Because clearly we need to know what the question is going to be asking us. And in this case, it's asking us that we need to make sure that we have the same number of strawberries and bananas in each snack pack, and as we are looking for what? The GC what? F. In this case, I will circle what's needed. In this case, it's GCF, right? Why? How do I know that? Because it says greatest number. The next thing is that I will restate the question. In this case, we were finding what? The greatest common factor. What is the greatest common factor of 9, right? The model that we're using, obviously we already identified that it says greatest number, so it's going to be what? G greatest. You guys get confused, Ms. Canella? I think somebody's in the chat chatting, so
Let me see.
eye on that.
No, we're good so far.
Okay. And then the next part is that we're gonna be solving, right? So in order to find the factors, guys, we need to make sure that we label this out correctly, right? So GCF, remember, is not multiplying. It's just factoring them out. So 18, what are the factors of 18? We have 1 times what?
18.
2 times 9. Is there anyone else? Yes, we do. We have 3 times what? 6, right? Those are the factors. The next one is 9. 9 times what? 1 times 9. 3 times 3. Any questions on that? How I got those? I don't think so. Okay, good. So now ICE is going to ask us, we just solved that the GCF is what, guys? Pay attention. Now we have 1 in common, we have 1 in common. We have 3 in common, we have 3 in common. But we also have what? 9 in common and 9 in common. In this case, the GCF is what? 9. Are we done yet? No. Now this is the part that you guys are not understanding. This same number idea right here, guys, that I just wrote down, same number, is exactly what we have to find out. If we have 18 bananas and 9 strawberries, how do we know how many goes in each? We know that we need to equal 9. So the way we do this is you have to divide. And when I mean divide, I mean this. How do I get to 18 having 9? So we have 18 divided by what?
9.
9 what?
There you go, Kiran.
Do what? 2 packs of what? 2 snack bags, right? 2 snack bags.
Of what? Is it the bananas or strawberries he's asking?
Somebody, I heard somebody speak. I'll just write it. Bananas, right? And then we have 9 strawberries, right? Now, clearly, how many snack packs we need? That's the easiest one, right? So 9 divided by how many to get 9?
9.
So we only need what? Guys, 9 divided by what?
1.
I'm trying to see if they entertained the conversation, but clearly they're not. So we need, there's 9 already here, so we know that it's only 1 snack.
Wait, 9 divided by 1 is 1?
No, I gotta fix that. Sorry. I was just trying to put 1 snack pack. It's 9.
Wait, you put, yeah.
That's right, right? Yeah.
Shouldn't it be 9 divided by 9 equals 1? Right? Because the GCF
Yeah,
is 9.
So,
There you go.
so it equals 1 snack pack. Does that make sense, y'all? What I did there? We actually, if you do this, we have an equal distribution between both. Does that make sense? Any questions on this before I erase it? Going once, going twice. So,
Okay, because you're going to have independent practice problems like this, so make sure you ask questions. And there's office hours today from 2 to 3. All right, let's look at problem 2. Mr. Art, awesome job.
thank you.
Number 2, a store is holding a promotion. Every 3rd customer receives a keychain and every 4th customer receives a magnet. So we're going to annotate 3rd customer keychain, 4th customer magnet. Which customer will be the first to receive both the keychain and a magnet? So I'm going to model this one. That way you see both examples, and then we're going to call on you. So I'm going to annotate 3rd equal keychain. 3rd equal keychain. The 4th customer equals a magnet. Now here's where it gets tricky. You have to ask yourself, what is this question asking for you to find? And it says, which customer will be the first to receive both a keychain and a magnet? So when will the 3rd and 4th customer meet up again? This is asking you to find the least common multiple because it's saying every 3rd. So it's 3, 6, 9. Or like every 2nd would be 2, 4, 6. So you have to find the least number, which is the LCM, under the annotation. We're going to put least, which means we find LCM. Now, obviously the question says, when will both customers get a magnet and keychain? Okay? Or which customer receives both? That might be easier. Which customer receives both keychain and magnet? Meaning we got to do the LCM, which means multiply, which means the numbers have to grow and get larger. So the LCM of 4 and 3. So we're finding the least common multiple of 3 and 4. Can we just write 3 and 4 under here, please? So now we're going to list the multiples of 3. So we're going to write multiples of 3. And what we do to find the multiples is we skip count. 3 times 1, 3. 3 times 2, 6. 3 times 3, 9. 3 times 4, 12. 3 times 5, 15. 3 times 6, 18. 3 times 7, 21. 3 times 8, 24. Now I'm going to go and I'm going to hit the enter space bar and I'm going to put multiples of 4. The same thing. We're going to skip count by 4. 4 times 1, 4. 4 times 2, 8. 4 times 3, 16. 4 times 4, 6. 4 times 3 is 12. 4 times 4 is 16. 4 times 5, 20. And 4 times 6 is 24. Now we're going to go and circle what numbers they both share. If I look at 3 and 4, they both share a 12. So I'm going to circle 12 on 3. Wait, they both share a 12?
I know.
It's okay.
'Cause you
They
said,
both share.
oh my God.
Go hit undo. Go hit undo. There's an undo at the top of the screen.
Can't move that circle, can I? Let me see. No, I can't move that circle.
Okay, so they both share 12 and they both share 24, right?
Mhm. I got it.
Perfect.
12.
12 and 24 they both have in common. So now I made a mistake when I did this question in my answer key and when I did the problems. Which is the smaller number, 12 or 24? Clearly, it's 12. So we're going to write LCM equal 12, which means which customer will be the first to receive both the keychain and magnet? Well, it's going to be the 12th customer to receive both. Right? Thumbs up if you understand. That was really fast. Let's see. Adam, Keelani, Emma, good Emma, Justin, Abigail. All right, this is Juliana, you're with us. Miss Lopez, you're with us.
Gerlin Garcia, I need you to turn on your camera, please, and leave it on.
Oh, let's add that name in. Yerlin. There she is. Okay. Awesome. Anyone have any questions? Because now,
I know that we spoke about iReady. Just a reminder for tomorrow, guys, cameras need to be on, okay? For your iReady exam tomorrow.
also too, you'll be able to go back and watch the video. Everything that we put up will be recorded and posted on Google Classroom. That way you could do well on your exit ticket and independent practice. And office hours today at 2 o'clock. All right, Mr. R, who's going to read this one? Who's on our list?
I was gonna ask you, but okay. Abigail, how are you? Abigail.
I knew you were going to call in her.
Abigail Torres. All right, guys, help me out.
Good.
Abigail.
What is the difference between finding the greatest common factor and the least common multiple of the numbers 4 and 12?
Good. So what are the factors of 4?
4, 8,
That's multiples, because that's skip counting, right? Factors is, I'll give you the first one. 1 times 4.
2 times 2,
Is there anything else? Trick question, right? No, there isn't, because nothing else goes into that. What's the factors of 12?
1 times 12, 2 times 6,
Mhm.
3 times 4,
Now let me ask you this. What is the GCF in this example? We know that they share 1, they share 2, and they share 4. 1, 2, and 4. Which is the GCF?
4.
Good. Everybody see how we got that, correct?
Yes?
Good. Now, who's
Let
next?
Justin B, Mr. R?
Thank you, Abigail. Who you said, Justin? Yeah, sure. Justin, get on down.
Yeah. Hey, Justin. You could have me.
Yeah,
Hey, how are you?
good.
Good. Can you give Mr. R and I and your classmates the multiples of 4, starting with 4? Skip count.
Multiples with 4?
Yes, skip count. Like 2, 4, 6, 8.
Okay.
So 4.
2, 4, 6, 8.
Starting with 4, buddy.
That's
Wait, what?
so
Starting with 4. So 4, what comes after 4? You double it.
4 times 1, 4 times 2, like that.
Oh, okay. So 4 times 1 is 4. 4 times 2 is 16.
Oh,
4 times 3 is 12.
wait, 4 times 2. What's 4?
No, 4 times 2 is 8.
There
Okay.
you go.
And then 4 times 4 is 16. And then 4 times 5 is 20.
4 times 3, buddy. That's 4 times 3.
4 times 3 is 28. I think.
Wait. Look, so you said 4 times 1 is 4, right? That's what you told us. 4
Yeah.
times 2 is 8. Add 4 more. What's 8 plus 4? That's what 4 times 3 is.
12.
There you go.
Yeah, I said 4 times 3 is 12.
Oh, I'm sorry, we didn't hear you.
Oh.
4 times 4 is what?
4 times 4 is 16.
And 4 times 5?
4 times 5 is 20.
And then 4 times 6?
4 times 6 is 24. I think.
Now multiples of 12, Justin.
Wait, what?
Now multiples of 12. 12 times 1 is 12.
12 times 1 is 12. 12 times 2 is 24. 12 times 3 is
You get the-
36.
Yep, but what is the LCM now in between these two numbers?
What do they have in common? Look, don't guess. Look on the board. Look, what do they have in common?
I can't see the board.
Oh. Let me stop
That's why.
sharing and I'll share again. Let me know if you see. Okay, hold on. I'm sharing it.
Emma, we see your hand. Emma, type in the chat what you need in the
Here
meantime.
now, Dustin.
Yeah, I can see it. I can see it.
All right, so what is the common that they share? 4, 8, 12, 16, 20, 24, or 12, 24, 36? Which one of these two they share in common?
They both have 12 and 24.
Good, right? 12 and 24. Now, what is the LCM? Remember, the L stands for what? Least, right?
Yeah,
So, which one is it?
the least.
So what?
Yeah, yeah. 12.
12.
Oops.
Oh, why I wrote like that?
Yeah,
Right
12.
now, Justin, real quick, help me out. What is the difference between GCF and LCM?
That GCF is the greatest and LCM is the least of the numbers.
Okay, one thing you have to add on to that. That's perfect start. There's one thing more. When you find the GCF, do you list or do you do multiples?
You do multiples.
Let's look. What does it say? What is that? When you list the two numbers that multiply to the product, those are called the factors, right?
Yeah.
Right? Factors are two numbers that multiply to the answer, the product. And the multiples are when you skip.
Count.
There you go. That's what we were looking for. So you had 90% of it. We just want the extra step.
Yeah. Yeah.
All right. On mute, all right? Thank you.
Wait, what?
Go back on mute. You did a good job.
Okay, thanks.
All right. Mr. R, do we have a next person?
That's why I was talking to Abigail through private chat. So,
Oh, you were
All right.
busy talking to somebody?
so we're good for that. Now the next one is remote problem 4.
Oh,
I
you didn't
have.
erase it. You didn't erase number 3.
Oh, I didn't. I'll do that now. Whoa, 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 whoa. Okay. I didn't think I'd do this for the last one either, right? No, I did not. Did I do it for this one? Okay.
Yes, we're all good.
Okay. Next person on my list. Adam.
Adam, you're up.
Oh,
Okay. So I read,
yes.
Miss Cannell makes balloons. Arguments, she has 32 blue balloons, 24 yellow balloons, and 16 white balloons. Each arrangement must have the same number of each color. What is the greatest number of arrangements that Miss Cannell can make if every balloon is used?
Good. So that's the first thing. And what are we finding?
What are we finding?
We're finding the greatest common factor.
Perfect.
And now what am I annotating? Well, what's already annotated? Talk to me.
Wait, I didn't hear.
What is already annotated? Talk to me.
Wait, let me just.
What are the key words is what he's asking.
Oh, the keywords. The
And
keyword. The keywords is 30, 32 balloons, 24 yellow balloons, 16 white balloons.
And what else? What
Uh,
kind of number? What kind of number? There's two more words. Same, different, what?
I don't see it.
It says each arrangement must have the,
Same number.
and then the question is asking for the, what kind of number?
What is the greatest number?
Perfect. That's how you told Mr. R you have to find the GCF, because the keyword greatest, GCF, yes?
Yeah.
So please restate the question for me. It says what?
It says each arrangement must have the same number of each color. What is the greatest number of arrangements that Miss Cannell can make if every balloon is used?
Which now means you're going to model. How are you modeling the problem? What are you finding?
I'm finding the greatest common factor
Of what numbers?
of 24 and 16
And there's another number.
and yeah, 32.
So the GCF of 32, 24, and 16. Okay, give Mr. R and your classmates the factors of 32. 1 times what?
1 times 32 is 32.
Okay.
2 times 32 is
Oh, okay, what's that?
Remember, we always trying to find the multiples that go inside of 32. So 2
Oh.
times the number equals 32. So what number is that?
Comes after 15. What comes after 15?
16.
Next one is what other numbers go inside of it? Does 3 go inside of 32? 3 times what? Oh, I got to get somebody. Hold on.
Wait, 3 does not go into 42,
Hold
right?
on, hold on.
Yeah.
So how about 4? 4 times, he's going to change that in a second once he omits them. 4 times what is 32? How many groups of 4 are in 32?
About
Someone said 6. Keep going.
7.
Keep going. One more.
8.
There you go.
Oh, 8.
4 times 8 is 32, right? Now you're going to give us the factors of 24 now.
Okay.
We always start in order from least to greatest. 1 is paired with what?
1 is paired with the 24.
Good. How about 2?
2 is paired with 24.
Oh, 2 times what? Remember Mr. R just told you.
Yeah.
Okay, it gets tricky.
2 times 12.
There you go. 3 times what?
3 times 4. I think 4.
Well, 3 times 4 is how much?
That's 16.
3 times 4 is actually 12. I want to get to 24, so I got to double that to 8.
Yeah, 3 times 8 is 24.
Okay, and 4 times what?
4 times 6, I think.
There you go. Perfect. All right. 4 times 6, perfect, is 24. Mr. R? Maybe he went to omit somebody? Mr. R? Mr. R? 4 times 6 is 36, is 24. Now, I don't know what happened. Maybe his laptop? Well, he's there. I don't know where he went. I don't see him. Mr. R? Okay. 4 times 6, Adam.
Unstable connection, Ms. Cannell. I don't know if you hear me.
Oh, now I can.
Hello, can you hear me?
Yes. All right, Adam. 1 times 16, 2 times
2 times 16.
Oh, remember, 2 times what is 16? We're finding two numbers that equal 16, remember?
Yeah. 7.
One more.
I mean 8.
There you go, Adam. And 4 times what?
4 times
Comes after
4
3.
times 3. And
What was 4 times 3? Because I went over that one with you before. 4 times 3 is
12.
so right. So we need to get to 16. So we have to do one more, which would be 4 times 4, right?
4 times 4. Oh.
Now you're going to circle what they have in common. Do they all share a 1, Adam?
No. Actually,
They don't all have a 1?
they do. They do.
Okay. Do they all share a 2?
Yes, they do.
Good. Do they all share a 4?
Yes.
Do they all share an 8? Do they all 3 numbers have an 8 in it?
Yeah.
So what is the greatest common factor of 32, 24, and 16?
8.
8, that's the first part. So the GCF is equal to 8. But if you go back to the question, it says, what is the greatest number of arrangements that I can make for every balloon? So the GCF is 8. Now we got to figure out how many bundles or packs of blue balloons do I need? So you're going to use what you multiplied. 8 times what is 32? Look right on the screen. 8 times what's its partner?
8 times I don't see it.
Right here on the top where it says 32, right?
Oh yeah. 8 times 4.
Good. So 4
How
blue,
many packs?
4 packs of blue balloons.
Yeah.
Now you go try 24, which is yellow. How many yellow packs of balloons do we need to get to 24? If we already had 8, 8 times, 8
2
times,
times
go ahead.
2 times 12.
2 times 12, right, but the GCF is 8. So 8 is paired with what number?
Oh, 8 is paired with 3.
There you go. So 3 packs of yellow. And now how many packs of white do we need? If we have 8, 8 times what? Give me 16.
Yeah, we need 2 times 8.
Mm-hmm. So 3 packs of yellow balloons and 2 packs of white balloons,
Yeah.
right? This is what your independent practice will be like, which will be posted after our lesson is completed for the day with your exit ticket. Does this make sense to everybody?
Yes.
Because if not, we have office hours today at 2 to 3 where we'll go over this again with you. And now's the time for you to ask us questions.
So I kind of want to reiterate, Ms. Canella, if it's okay with you.
Yeah, do the other.
Because, okay, Adam, this is strictly for you right now that I'm doing this. But if you look at this, in between all 3 numbers, the 32, the 24, and the 16, we have a common number that's 8, which is considered our GCF, which stands for the greatest common factor. What that pretty much means is that in between the 32 balloons that we already have, the 24 yellow balloons and the 16 white balloons, we have to make sure that we have these numbers of packets, the 4 packs of blue balloons, the 3 packs of yellow balloons, and the 2 packs of white balloons in order to make sure that we have an equal distribution. How do I know that? Because it says in the first lane right here, it says same number. Do you see this? Where it says same number? Right here, it says it real nice. It says same number, meaning we have to have an equal distribution for the same number of packets. Does that make sense?
Yeah.
Okay. Any questions on that, guys? Like Ms. Canelo just mentioned, you will have to do this alone, and this is going to be graded as your classwork. So if you have any questions, now is the time to ask. You can simply use the raise your hand feature or talk, say something.
No, I understand it now. No, I got a better understanding of it.
Okay. All right, guys. I just don't want you guys to get stuck, you know? All right. The next one is, this is me. I'll go over this.
That was yours. And then we have the exit ticket and we're done.
Yep. Okay. I can't erase these two, Ms. Canal. I think that's you. Okay. So, here goes, guys. So, I'm going to read the question and then I'm going to answer it. Pay attention, please, and thank you. So, McKaylin has 12 jars of jam, 12 jars of grape jam, 16 jars strawberry jam, and 24 jars of raspberry jam. She wants to place the jam into the greatest possible number of boxes. So each box has the same number of jars of each kind of jam. How many boxes does she need? So 16 jars of strawberry jam and 24 jars of raspberry. I have to admit somebody else, Miss Canella.
Okay, is it Remesis?
It's Juliana.
Oh, she probably got kicked out because she was in.
I'm just confused because I'll explain later. Okay.
Okay.
So when we restate this question, oh yeah, I forgot something, right? What if I get same number?
And you forgot, that's it,
Greatest.
greatest number.
Right now on the very top, it says restate your questions. Clearly, I'm trying to find what is the GCF of 12, 12, 6. And then the model, I'm gonna find the greatest
Greatest.
common factor.
The greatest common factor. There we go. 12, 16,
12, 16.
and 24.
Since we're running short on time.
I know, I noticed that. Oh wait, it's a little small, Mr. R.
Okay. It is on 24. I don't know why. But.
There we go.
All right, guys. Now we gotta solve, right? So in order to find the greatest common factor, we gotta see what goes inside of each number. So Adam, again, just to repeat, and everybody else that needs help, we're gonna list the factors of 12 first. Clearly, we know that 1 times goes into 12. 2 times what number goes into 12? 2 times, in this case, is gonna be 6.
3
And then
times.
we go in order. See, 1, 2, and then the next one is 3. 3 times what? 4 goes into 12. All of these equal what? 12. Those are the factors of 12. The next one is the number 16, correct? So the first one is 1 times 16, which everybody knows is the easiest. 2 times what number? 8 goes into 16. And then we have
4.
Times what? 4, right, guys? So far, so good, Miss Canella, right? 24.
Sure.
We have 1 times 24. We have 2 times 12. We have 3 times, nope, 4 times.
Wait, 3 times 8.
Yeah, 3 times 8.
4 times. You're right. 4 times.
6.
Perfect.
Right now, we notice we start circling again. I have to admit, hey, Ramsey, Gautier, okay.
Okay.
I cannot stress. Don't be late, guys. 1 is in common, right? And then we have to look for the GCF. So we got to look at the number that is actually all in common. 2 is in common, right? How about 3? 3, no, 3 is not in common. 4 is in common, right? 4 right here, 4 right here, 4 right here. What about 6? 6. No, so in this case, what is the greatest common factor? The GCF
4.
in this case is going to be 4. However, we are not done yet. That means we need 4 what? GCF equals 4. We know that we need the greatest common in order to have the common in between all of them and have the same number. I reiterate, same number. I'm going to mark this up. Right here. I don't know why it's not marking up.
Well, you have to pick a color. Pick yellow or green or something.
Yeah.
Yeah, there you go.
Okay, twice, but it's not picking up. Now it wants me to do it.
There you go. I see green.
Okay, well, same number, right? So we know that we need that. That means that the GCF is 4. So I'm going to write down the actual mathematic steps, which is also on the right-hand side. We don't really need to do it this way, but we know that 4. So 4 times a number equals 12. So how many packs of strawberry jam do we need grape jam do we need first?
3.
We need 3 grape packs of grape jam. We need the next
4.
one, 4
Because
packs of grape. I'm gonna explain it afterwards.
Strawberry.
Of strawberry. Another person is gonna. I don't know. Andrew, isn't that the next section? Yes, it is.
It is. So don't admit him.
Yeah. All right, I'm gonna finish this. And then we need what?
We need 6 raspberry.
Now, if you guys do the math, 4 times 6 is 24, right?
Mm-hmm.
4 times 4 is 16, and 4 times 3 is 12 to have the equal numbers on the left-hand side, but this is the correct answers right here.
Should we go over the exit ticket real quick? We'll be like an extra few minutes over.
Sure.
All right. Oh, we already wrote it in. All right. So it says pencils are sold in packs of 12 and erasers are sold packs of 8. Ms. Canella and Mr. R want to give each student a pencil and an eraser. The key word is least, so I have to find the LCM. This is your exit ticket that will be shared later on. You're going to write all the multiples of 12, which you're going to do on your own. And then you're going to write all the multiples of 9. And then you're going to find the LCM. And then you have to go one more step and find out how many packs of pencils do I need and how many packs of erasers. It will be a multiple choice. So again, just like we did in class, we found either the LCM and GCF, and then we had to go back to figure out how many packs or how many numbers of something we needed. So once you have the LCM, you then can figure out, okay, if the multiple, say here was like 36 or whatever it was, I would need 3 packs of pencils and 4 packs of erasers because the LCM is 36. 12 times 3 and 9 times 4 is 36. Again, if you need more help, please reach out. Mr. R and I will be sending out the link around 1:50 today for office hours. We will review this and your independent practice problems. Please come. We love to see your faces.
I'm gonna say this in once and only once, guys, and I don't know why my camera was off this whole time. That's ridiculous. I had it on the whole time. Ramsey and all these other people. Listen up, guys. So asking questions and actually participating and doing it properly and working less with it is the best way to be more efficient. Honestly, like I'm only here for you. That's the only reason. If you can't understand this, then I got something that I'm doing wrong, and I have to repeat myself 1,000 times if I have to, right? So it's on you. Remember, today's office hours starts at 2 and it ends at 3. I highly advise you guys, those of you that are confused still about GCF and LCM, to come. I'll reiterate, I'll go over it. I will watch a video. There's also a video on Google Classroom. If you don't want to hear me, you can hear Ms. Canella speak in the video. That is fine. However, I need to make sure that you guys are understanding this. Because tomorrow, remember, I'm ready for 3 hours. You cannot turn off your cameras. Like, come on, guys. Right? Wake up, smell the coffee, drink some soda. I don't know. I can't tell you that, but you guys get the point. Like, just wake up. Right? And you guys are definitely free to go because it's already 10:48. Class ends at 10:45. But definitely attend office hours if you need to.
And one other thing, guys, you have to keep those cameras on.
Justin, I don't know what's wrong with your camera, buddy, but that camera has to be on. I could care less what's going on behind you, honestly.
Yeah, we're just here. We show up every day for you, you know? That's why we're here.
One of the reasons we're doing this camera situation is because, guys, I'm a gamer myself. I know that you can play games while having your cameras off. I'm not dumb, right? So you gotta relax with all that and focus more on what's important, which is this. Savvy? Savvy? Thumbs up, thumbs up, thumbs up, thumbs up, thumbs up. Yes, good. Yes, understand. Cool. If you have any questions, guys, you can definitely reach out via email if you need me. But remember, today's office hours is on there, and you also have that link of that office hour is also already on Google Classroom. Look for it, read, and you'll get there. I promise.
Mr. R, I think we should maybe when we finish at 1:45, we can just post the link on Google Classroom for them.
That too, we could do that too.
On Zoom. That way you don't have to check
I'm
your
gonna use
email.
the same link. Use the same link.
Yeah, we'll just schedule it so every Tuesday, Wednesday, Thursday. Yeah, that's what we'll do for you guys. All right. All right,
Yeah.
folks. Hope to see you then.